Configuring and deploying an operating system can take a lot of time and resources. That's why Red Hat Enterprise Linux provides built-in automation to help. My name is Brian Smith, and I'm a product manager at Red Hat. Today I'm going to demo how the Cryptopolicies RHEL System Role can help you implement consistent system-wide cryptographic policies across your environment. RHEL System Roles are a collection of supported Ansible roles that can help you automate and manage your RHEL environment, ensuring consistent and repeatable configuration. In this video, I'll be focusing on the Cryptopolicies System Role. This role can implement a specified system-wide crypto policy across your environment. When changing the system-wide crypto policy in a system, by default the role forces a reload of some of the daemons affected. It's also possible to have the role automatically reboot hosts if needed, although this is not enabled by default. This role supports RHEL 8 and later hosts. The demo environment consists of a RHEL 8 control node named controlnode.example.com and 3 managed nodes, all of which are running RHEL 8. My desired system-wide crypto policy configuration in the environment is having the future policy implemented on RHEL 8 Server 1 and RHEL 8 Server 2. For the RHEL 8 Server 3 hosts, I would like to use the default policy with the no SHA-1 policy modifier to disable SHA-1 in signature algorithms. Now that we've outlined the demo environment and our desired configuration, let's get into the demo. I'm logged into a RHEL 8 control node where I've previously installed the RHEL System Roles RPM and the Ansible Engine RPM. I've also set up a service account named Ansible on the control node and the managed nodes that I'll use. For more information on these steps, refer to the Introduction to RHEL System Roles blog post that is linked in the video description. Each role has a README file that outlines the role variables that can be used. I'll start by looking at the README file for the Cryptopolicies role, which is available at user share doc, RHEL System Roles, Cryptopolicies, readme.md. The README specifies that by default, the role will just report the system status. It also notes that the Cryptopolicies policy variable can be set to specify the desired crypto policy. The Cryptopolicies reload variable, which defaults to true, controls if the role should force a reload of some of the daemons affected by the crypto policies in the system. The Cryptopolicies reboot OK variable, which defaults to false, controls if the role should automatically reboot host if needed. The README also specifies the variables exported by the role. The Cryptopolicies active variable returns the currently active policy name. The Cryptopolicies available policies variable returns a list of base policies available. The Cryptopolicies available modules variable returns a list of all policy submodules available. And finally, the Cryptopolicies reboot required variable returns true or false depending on if a reboot is needed to apply the changes made by the role. I'll start by changing into the gather info directory. Within this directory, I have a playbook named gatherinfo.yaml. This playbook will run the Cryptopolicies role to gather the current status and display the results of the Cryptopolicies active, Cryptopolicies available policies, and Cryptopolicies available modules variables that were previously mentioned. Within this gatherinfo directory, I also have a basic Ansible inventory file named inventory.yaml, which contains a list of my 3 managed nodes. I'll go ahead and run the gatherinfo.yaml playbook using the Ansible playbook command and then come back once the playbook's completed. Okay, the playbook successfully completed, and I can see that on each of the 3 systems, the default policy is the currently active policy. I can also see a list of available policies and policy modules on each of the systems. Next, I'll change into the Cryptopolicies directory. Within this directory, I have another Ansible inventory named inventory.yaml. This inventory file defines 2 inventory groups. The first group is named Future Policy and contains the RHEL 8 Server 1 and RHEL 8 Server 2 host. The second group is named Default Policy No SHA-1 and contains the RHEL 8 Server 3 host. I have a group vars directory that contains YAML files to define the Ansible variables for each of these 2 inventory groups. We'll look at the futurepolicy.yaml file, which will apply to hosts in the future policy inventory group. In this file, I have the Cryptopolicies policy variable set to future to specify that this is the policy I would like to implement it on the host belonging to this inventory group. Next, we'll look at the default policy no SHA-1.yaml file, which will apply to the host in the default policy no SHA-1 inventory group. In this file, I have the Cryptopolicies policy variable set to default no SHA-1 to specify that I'd like this policy to be implemented on the host belonging to this inventory group. Next, we'll take a look at the playbook that's named Cryptopolicies.yaml. This playbook will call the Cryptopolicies System Role and then show the value of the Cryptopolicies reboot required variable, which will indicate if a reboot is needed on the host to apply the changes. I can run the playbook with the Ansible playbook command, specifying I'd like to run the Cryptopolicies.yaml playbook, utilize the inventory.yaml file, and specify the -b argument to indicate that Ansible should escalate privileges. I can also optionally specify the -e flag to set the Cryptopolicies reboot OK variable to true, which would cause the role to automatically reboot the host if needed. However, in this example, I don't want the role to automatically reboot the host, so I won't set the Cryptopolicies reboot OK variable to true. And I'll go ahead and pause the video here and come back once the playbook has completed. Okay, the playbook successfully completed and also reports that a reboot is needed on each of the systems to apply the change. To validate my desired system-wide crypto policies were implemented, I can change back to the gatherinfo directory and run the gatherinfo.yaml playbook again. Once this playbook completes, it will show that the RHEL 8 Server 1 and RHEL 8 Server 2 hosts are using the future policy, and that the RHEL 8 Server 3 host is using the default policy with the no SHA-1 module, which matches what my desired configuration was. Thank you for watching. If you'd like to learn more about Red Hat Enterprise Linux, start your free trial today at redhat.com/try RHEL.